So there's another way to determine a solution to a linear system algebraically, and that's by the process of elimination. What we'll do is we'll choose a variable x or y or whatever variable they give us. We'll choose one of those variables to eliminate. Then we're going to modify by multiplying or dividing one of the equations so that the coefficient of the variable to be eliminated is the same for both equations, but with opposite signs. So like say you want to eliminate x, if one of the x's is positive, the x in the other equation should be negative. Then that way we can eliminate the variable by adding equations. Then we can solve for the remaining variable, substitute our solution to solve for the other variable, and then as always, we test. Okay, let's go through these steps with examples. So our system has x plus y equals 10 and x minus y equals 6. So let's write both of those. X plus y equals 10. That's one equation. X minus y equals 6. Now here you can say, hey, let me choose to eliminate x. But I'm going to say it's easier to choose to eliminate y. Because if you look at y already has the same coefficient to both equations. You have a 1y, a plus 1y, a minus 1y. So that's the same coefficient. And you already have opposite signs. One's a positive 1y, one's a negative 1y. So what you can do now is you can add the equations, and when you do so, you're going to eliminate the variable. Let's see how that works. So x plus x is just 2x. A positive y minus, or a positive y plus a negative y is just 0. So that goes away. Then you have 10 plus 6 equals 16. So I'd say this was your step A and B here. Then step C is when you added the equations and you eliminated a variable. Step D says solve for the remaining variable. Okay, so you have 2x equals 6. Step D will be x then equals 16 over 2, or 8. How did I do it? I divided both sides by 2. And then you can do step E, which is substitute that equation, or that value, into one of the other equations. Okay, you can choose to substitute into any equation. I'll just substitute into the first one. So step E now, instead of x plus y equals 10, you can say 8 plus y equals 10. Then we can solve for y. Y equals 10 minus 8, or y equals 2. There's your solution. The intersection, or the solution, occurs at x equals 8, y equals 2. What do we like doing? We like testing these out, right, to make sure we're correct. So to test, we'll plug in the values in both equations, and the equation should hold true. So we have 8 plus 2 equals 10, 10 equals 10, that works. For the other equation, 8 minus 2 equals 6, 8 minus 2 equals 6, that equals 6. Okay, the testing works as well. So next example, we have 2x plus y equals negative 7, and x plus y equals negative 4. We can choose to eliminate the x, and if we do so, we would want to multiply this equation by negative 2, so we can get a negative 2x. But probably the easier way is if we multiply that second equation by a negative 1. And if we multiply one of the sides by negative 1, or the equation by negative 1, that means we're multiplying both the left and right side. Why am I going to do that? Let's see. The first equation is 2x plus y equals negative 7. The second equation, we're multiplying by negative 1. So negative 1 times x, let me do it like this, negative 1 times x is a negative x. Negative 1 times y is a negative y. And then you have negative on the other side of the equal sign, negative 1 times negative 4, which is a positive 4. So I did that because look at the y's again. If I add these two equations up, the y's plus y and minus y are going to cancel out. The y's will be eliminated. So let's go ahead and add the equations. 2x plus a negative x is 1x. The y's are canceled, plus y minus y equals 0. Then we have negative 7 plus 4, which is a negative 3. So we have x equals negative 3. Perfect. X equals negative 3. We can use that, plug it in an equation, and we can solve for y. So we'll plug it into that equation there. X equals negative 3 plus y equals negative 4. So this is my solution to x. Let me be clear. Then I'm starting here with substituting that negative 3 value for x in the x plus y equals negative 4 equation. Now I can solve for y. Y equals negative 4 plus 3. So I can add 3 to both sides of this equation. So negative 4 plus 3 is a negative 1. Okay, let's test this out. First equation was 2x plus y equals negative 7. So 2 times x plus y, does that equal negative 7? 2 times negative 3 is negative 6, plus a negative 1. Does that equal negative 7? Negative 6 plus negative 1 equals negative 7. That equals negative 7. That test works. Second equation, the original equation was before I multiplied by negative 1, was x plus y equals negative 4. So x plus y equals negative 4. Is that true? Negative 3 plus negative 1 is negative 4. That equals negative 4. That works out just fine. So the solution of negative 3 and negative 1 work. So with the next one, it might not look so easy to eliminate, but it's not bad. You have a 6x and a 2x, and a negative 5y and a 3y. So if you think about what's going to be easiest to eliminate, it'll be the x's, because you can just take that second equation and multiply the second equation by 2. Doing so will give you 6x, which matches the 6x in the first equation. And what we want to do is get that 6x, but we want to change the sign to be negative, so that when we add the equations, the x's will be eliminated. Let's go ahead and try that. So our first equation was 6x minus 5y equals negative 2. The other equation, it will multiply by negative 2. Oh, sorry, that should be a negative 3. Let me modify that. This should be negative 3. Negative 3 times 2x is a negative 6x. Negative 3 times 3y is a negative 9y. On the other side of the equation, negative 3 times 18 is a negative 54. Then we add the equations together, and we do this so we can eliminate a variable. In this case, we'll be eliminating the x. 6x plus negative 6x is 0. It got eliminated. Negative 5y plus a negative 9y is a negative 14y. And negative 2 plus a negative 54 is a negative 56. Okay, now we need to solve for y. We have negative 14y equals negative 56. So that was our result from adding the equations. Solving for y, which will divide both sides by negative 14, we'll have y equals negative 56 over negative 14, which is 4. Now that we have a value for y, we can substitute that value into any one of our original equations and then solve for x. So let's take that y, plug it in the first equation, see what we get. So we have 6x minus 5 times y, which we said was 4, equals negative 2. So then 6x minus 20 equals negative 2. Solving for the x, still we can add 20 to both sides. 6x equals negative 2 plus 20, which is a negative or positive 18. And then finally, we can divide both sides by 6. X then should equal 18 divided by 6, which is 3. So we have a solution of x equals 3 and y equals 4. We can test it out. Let's test that first equation. 6 times x minus 5 times y. Does that equal negative 2? 6 times 3 is 18. Minus 20. Does that equal negative 2? 18 minus 20 is negative 2. That equals negative 2. That test works. Testing the second equation. 2 times x plus 3 times y. Does that equal 18? Well, 2 times 3 is 6. 3 times 4 is 12. Does that equal 18? 6 plus 12 is 18. That does equal 18. Our solution of x equals 3 and y equals 4 works. It is the solution or the intersection to that system of linear equations. This next example, you have 3x and 5x, also negative 4y and negative 6y. Now, you could choose to multiply one of those equations by a fraction in order to line up your coefficients for either the x or the y, or you can modify both equations by multiplying. Let's modify both equations, because I know some of you don't really like fractions too much. So let's choose what to eliminate. I'm going to choose y. So I think about eliminating y. I have a 4y, or negative 4y, negative 6y. The lowest common multiple of 4 and 6 is 12. So basically I want one equation to have 12y and the other equation to have negative 12y. Doesn't matter which one. Let's say we take the first equation and multiply this by a negative 3. So multiply that first equation by negative 3. That would give us a positive 12y. And if I take the second equation, I'll multiply that by 2. 2 times negative 6 is negative 12. That gets us a negative 12y as well. And then let's line up these equations. Negative 3 times 3x is a negative 9x. Negative 3 times negative 4y is a positive 12y. Negative 3 times 7 equals negative 21. For the second equation, 2 times 5x is 10x. 2 times negative 6y is negative 12y. And then on the other side of the equals, 2 times 8 is 16. So notice that the coefficients of y are both 12 and the sign is different. One's a plus, one's a negative. That way, when we add these equations together, we'll be eliminating the y. Negative 9x plus 10x is a positive 1x. The y's, as we say, get eliminated. Negative 21 plus 16 is a negative 5. So x equals negative 5. Take that x, plug it into any of those original equations. I'm going to just choose to plug it in the second one. We'll have 5 times x minus 6 times y equals 8. Now we solve for y. Negative 5 times 5 is negative 25. Minus 6y equals 8. We can add 6y to both sides, subtract 8 from both sides, and we'll get negative 25 minus 8 equals a positive 6y. Negative 25 minus 8 is a negative 33 equals 6y. Y then equals negative 33 over 6, which is, as a reduced fraction, 11 over 2. So y equals 11 over 2. Sometimes you just can't escape fractions. Okay, so we have our solution, and we can test it out now. Looking at the first equation, it's 3 times x minus 4 times y. Does that equal 7? So 3 times negative 5 is negative 15. Negative 4 times a negative 11 over 2 is a positive 22. Does that equal 7? Negative 15 plus 22 does equal 7. So that looks good. For the second equation, 5 times x minus 6 times y, does that equal 8? So negative 25 plus 33, does that equal 8? Yes, it does. So our solution of x equals negative 5, y equals negative 11 over 2 is correct. Last one, let's make some equations out of these scales. On the first one on the left side, you see 3 x's, so that's 3 times x, plus a y. That is equal to 10 plus 5 plus 1 plus 1. That's 17. For equation 2, you have 1x plus 1y equals 5 plus 1 plus 1, so that equals 7. Okay, so what I would do, so I'm looking at those two equations, it looks like the easiest thing to eliminate is a y, and I can do that by multiplying that second equation by a negative 1. So we have 3x plus y equals 17, and then negative 1 times x is negative x, negative 1 times y is negative y, negative 1 times 7 is negative 7. So I'll add those two equations together. 3x plus a negative x is 2x, the y's cancel, 17 plus a minus 7 is 10. So from there we can solve for x, divide both sides by 2, x equals 5. So we'll take that solution for x and put it in another equation. So 3 times x, that's 3 times 5, plus y equals 17, and we want to solve for y. So then you have 15 plus y equals 17, subtract 15 from both sides, and you'll end up with y equals 2. So your solution is x equals 5, y equals 2, and then you can test it out. Testing it out, we have 3 times x plus y, does that equal 17? 3 times 5 is 15 plus 2, does that equal 17? 15 plus 2 is 17, that equals 17, we're good. Next one to test is x plus y equals 7. X plus y, does that equal 7? 5 plus 2 is 7, that does equal 7. Looks like our test is good, so x is 5, y is 2, that is our solution. Thanks.